Hello viewers. This is my technical channel, C Technical. So, in this video, I wanna teach you the uh, live in this video. So, in this live, I tell you about the to verify truth table or and not and nor and NAND gates. So, please watch the complete video. Sorry, the complete live that you can know about this technical things. So let's start our video to verify your truth table or R and not nor and NAND gates. So the function of the digital system is described by two uh, discrete states respected by 1 and 0. 1 mean on and 0 mean off, called binary digits. For the binary digits, the Boolean algebra is used. The Boolean algebra is used upon their basic logic operations. For example, so in this technical channel, I discuss the OR gate. You can see here as the OR gate operation, the AND gate operation, I tick, you can see, and the NOT gate operation. Okay, so these three are the main gates. So first I discuss this OR operation. So output of this OR operation is equal to C equal to A plus input A plus input B, which mean any operation which are 0 or 1. If you sum this two operation, the result will the sum of two operation, the result will equal to the output. So this type operation is called OR operation. The second one is AND operation. AND operation, A input multiply by B input, so equal to the C output. So this is the AND operation. And the NOT operation, uh, the A input A read is a bar which is used to invert. It's mean that A inverse equal to C output. The electronic circuit which use these logic operation are called logic logic gates. The logic gates has one or more input but only one output. The high voltage at the input or output is said to be in a logic state, which mean on and low voltage is mean the logic state is 0, which mean off. The three basic logic state are OR gate, AND gate, and NOT gate. The combination of these gates will each other give the desired gates, which is NOR gate and NAND gate. NOR gate is the combination of OR gate and NOT gate, which invert the output of OR gate. NAND gate is the combination of AND gate and NOT gate, which inverts the output of the AND gate. The table which given operation of logic gates is called truth table. If we put input A and B and the output and C, then the truth table of these logic gates will be equal to, so you can see this is OR gate. So this is OR gate operation. This is logic gates, OR gate and AND gate. So I discuss in diagrammatically. So here you can see A is the input and B is the input. this is our get. So if we provide a signal, for example, if we provide 0 and b is 0, so the output of this get is 0 because here is no signal. So if the output of a is 0 and the b is 1, so the output of this get is 1 because this is addition. 1 plus 0 is equal to 1. So if I this input is 1 and this is 0, so the output is 1, again 1, because this is addition, sum. So the output of this gate is 1 and this is also 1, so the output of this gate is 1. So here you can see in the table, if the input A input is 0 and the B input is 0, so if we add this, so it equal to 0, the C will be 0. If the input A is 0, the input B is 1, so the sum of this is 1. Also 1 plus 1 is equal to 1 and 1 plus 1 also is equal to 1. So this is the OR gate operation. So I discussed the AND gate operation. So this is a diagrammatical structure of AND gate. So the input A and the input B. So if provide here is 0 and here is 0. So if we multiply this 0, so 0 multiplies 0 is equal to 0. If we and provide input 1 and here is also 1, so the 1 multiply, oh, sorry, here is 1 and here is 0, so 1 multiply 0 is equal to 0, so this is again 0. If here is 0 and here is 1, so it is again 0. If here is 1 and here also 1, the both input is 1, so 1 multiplied by 1 is equal to 1. So this is the output operation. So here you can see 0 multiply 0 is equal to 0, 0 multiply 1 is equal to 0, 1 multiply 0 is equal to 0, 1 multiply 1 is equal to 1. So this is the AND gate operation. So now I discussed the NOT gate. So here you can see this is the NOT gate. This is the diagrammatical structure and symbol of NOT gate. NOT mean it's inverse. Inverse means if the input is 0, so the output is inverse. It's mean it's 1. So the input is 1, so the output is 0 because this is the invert. The input is also inverse by the output. So uh, this is the input of NOT gate. Here you can see 1, so here is 0, so the output is 1 because it is inverse, that we call that is NOT gate. If the input is 1, the output becomes 0. So now I discuss the NOR gates. So it is NOT gate and that is NOR gate. So the input of NOR gate is AB. So the output of this, it's mean that if you provide some input, it's invert mean it convert to NOT gate and then you can see your result. So this is diagrammatical structure. C is equal to A plus B and to inverse matlab not. So this is the combination of AND gate. So I discussed diagrammatically. Here you can see this is input data. For example, I provide 0 and 0. So if we add these two digit, 0 plus 1 is equal to, sorry, 0 plus 0 is equal to 0, and then we invert this 0, that will become 1 because this is NOR gate. So if we provide input A as 0 input B as 1. So 1 plus 0 is equal to 1, but this is NOR get, so we inverse this one, it will become 0. You understand? So if we provide input 1 and B is 0, so if we add these two, this will become 1, but if we invert this one, this will become 0. So if we provide 1 A and B 1, so if we sum that these two digits, so it will become 1, but if we invert the 1, so this will become 0. So now I discuss the NAND gate. So the NAND gate structure diagram is given below. You can see the input of NAND gate is A, the input of uh, NAND gate is B. So if we want to result, C is equal to A inverse multiplied by B inverse. So here you can see there is the not symbol. That's invert. Invert mean that the input is 1, it will become uh, 0. So now I discuss. So 0 plus, so 0 multiply 0 is equal to 0, and up, and then we invert this 0, it will become 1. So 0 multiply 1 is equal to 0, and if we invert this, this will become 1. So 1 multiplied by 0 is equal to 0, and if we convert this 0, so it will become 1. So 1 multiply 1 is equal to 1, and if we convert this 1, it will become 0. So now I discuss this. There's a truth table for the gates can be verified by having a logic units mounted. So on a small board with the socket for the power supply input A multiply A and B, and the output is C. A high input is obtained by the connecting the input socket to the positive of the power supply and low is 0 volt. The input can be determined by using an indicator lamp LED. So apparatus, DC power supply 5 and 8 volts are gate, AND gate, NOT gate, NOR gate, and NAND gate. So LED indicator models connecting wire with a crocodile clips. So procedure to verify the truth table, here you can see this is the power supply, this is the phase wire, this is the neutral. So this is the phase wire and this is the neutral. So if we provide this here and neutral from here, so the neutral of this power supply output here is LED. We connect to the LED input, and the phase of this is connected to the gate output. So the output of this gate is a two phase. If we connect it, this is K1 and this is K2. Here is the two switch, and this again is connected to the phase wire. So procedure make the connection as shown in the circuit diagram. Switch on the power supply, keeping the key K1 and the key K2 open. The LED will be not glow, which it mean the state A is equal to 0, B is equal to 0, C is equal to 0. So I discuss this all in detail. So, and this is my live lecture about the CK Technical channel. So please, I request you, please subscribe my technical CK Technical channel for more informative video that I make a technology video about this channel. So please watch my complete video, complete tutorial, and please subscribe for more video that I will make the more video for you guys that you can enjoy the latest technology about this CK technical education technical channel. So I request to please subscribe it and press the bell icon that you will never miss the latest video. Okay, thanks for watching and goodbye. Take care yourself.